There we go. So number five says a football is kicked by Joe, apparently, at an angle of 50 degrees above horizontal with a speed of 20 meters per second. Draw a picture of the initial velocity vector. So there it is, 20 meters per second, 50 degrees. And then you do cos. Cos gives you the adjacent side or the x component, right? Sine gives you the opposite side. And we expect this side to be bigger than this side, and that's because that's an awkward angle, right? It's bigger than 45 degrees. Yeah? Are we good so far? Yeah. So just a little double check. This becomes your initial and final velocity horizontally. This becomes your initial velocity. And then if it's a level field, which we all hope it is, right? Then that becomes the final velocity is negative the initial, right? And then to find time, VF is VI plus AT is the very best way to do that. And then just be careful, you don't want to round if the time, you probably want to write down more digits for the time, but there it is, right? So like if we're dealing with a couple digits, maybe write down 4 digits there. But once you get the time goes in here, it goes across, and then you can go, and the only thing you ever do on this side is that x is VI times t, right? So that's all, we're always just multiplying a velocity by a time. So it's this velocity, this velocity by this time gives us that. Is that right? Are we good? Yeah. So that's sort of the standard arc trajectory problem. How far does it go? How long is it in the air? This one that's on the screen is where we go off a cliff, and so we can't say that this is 0. This guy's going to be something besides 0, right? And we're going to have to figure it out. How about number 6? Are we okay on 6? 6 was good. They're all about the same, aren't they? I don't think there's any